Okay, so we're going to be solving systems of equations by graphing. So when do we do that? Well, we want to, whenever we give two equations that are already in the slope-intercept form, like they are here, y equals mx plus b form, then that is a great time to use graphing. Let's take a look at this first one here. So if we want to graph y equals negative 2x plus 4, we simply go to 4 on the y-axis. So 1, 2, 3, 4, and we place our point. Okay, and then we have a negative 2 slope, so we're going to go down 2 and to the right 1. And we repeat this process. Now for solving systems, I highly recommend that you do the counting method here like I'm doing for the entire grid. And the reason I suggest that is because if you are a little bit off when you draw your lines, you're going to find that you have a different point of intersection, which is what we're going to be looking for. Okay, so here we have our line. Okay. So that's our first line, y equals negative 2x plus 4. Okay, then we pick another color, y equals x minus 2, so we go to negative 2 on the y-axis, and we place our first point, and then a no number written in front of x, remember, is an understood 1, so we're going to rise 1 and run 1, or up 1 to the right 1. Okay, or we can go down 1 and to the left 1. All right, and we go ahead and draw our line through. Okay. And hopefully you can see that these two lines intersect right here at this point, which is 1, 2, positive 2, up 0. So the solution is 2, 0 for this system. Okay. Let's take a look at another one. All right, now this one I probably would have rather used either substitution or elimination to solve these two because neither one is in the y equals form, but I want to show you can totally still do graphing. All you need to do is solve these for y. Okay, so we're going to come over here to the sign. We're going to say x plus y equals negative 2. So we want to get y by itself, so the x has to go, so we subtract it, and we do on both sides. So we get y equals negative 2 minus x, or you could write it negative x minus 2. It doesn't really matter. Come over to our grid, and we place a point at negative 2 because that's where we're going to begin. And we have a negative 1 slope, so we're going down 1 and to the right 1. Or up 1 and to the left 1. Okay, and then we draw our line through the points. And there's our first line. Okay, so now we go and we do the same process for the second equation. So we have 2x minus 3y equals negative 9. We're going to solve for y. So I know that the 2x has got to go because y needs to be alone. So we have negative 3y equals negative 9 minus 2x. Then we divide everything by negative 3 because again y needs to be alone. needs to be isolated. So we have y equals 3 plus, and it's plus because of a negative and a negative, right, or a minus and a negative, however you want to say that, 2/3, and I leave it 2/3 because it won't reduce, it won't simplify from there. Okay, so that means I'm going to go to 3, right, so 1, 2, 3 on the y-axis, and then I'm going to rise 2 and run 3, or go up 2 and to the right 3. Okay. And again, I'm going across the grid completely. And then I draw my line through. And I look for the point of intersection. And I see that right here is my point of intersection. So that's my solution, and that is at 1, 2, -3, +1. All right, let's look at another one. Okay, again, that would not be my first choice to do graphing on this because we have x equals 3. I would probably use substitution. However, I want to show you that we can still use graphing. Okay, so we're going to solve for y. Ooh, I probably shouldn't write in yellow. It doesn't show it very well. We'll go with blue. Okay. Okay, so we start off with 4x minus 3y equals 6. We're going to get y by itself, so we're going to take the 4x away. And what we do to one side, we do to the other. So we have -3y equals 6 minus 4x. We divide everything by the -3 so that y is indeed alone. All right, so we get y equals -2. This time we're going to minus and minus. We're going to have plus. 4 divided by 3 won't simplify, so we simply leave it as 4/3 x. So that tells us we begin at -2 on the y-axis. We rise 4, and we run to the right 3. And repeat. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Okay, and going the opposite direction, down 4, 1, 2, 3, 4, to the left 3. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Okay, and we connect the dots, or draw our line, which would be more accurate. Okay, and we... All right, so there is the line 4x minus 3y equals 6. Now we want to graph our other line, which is x equals 3. And we know that if x equals 3, we go on the x-axis to 3. And this will be a vertical line through that point. So we just draw a vertical line. Through that point. And then we look to see where do the lines intersect. Right here is the point of intersection, and that is at 1, 2, 3, 1, 2. So 3, 2 is our solution. All right, let's take a look at another one. Okay, the equations of two lines are y equals 5 and x equals -7. Okay. So y equals 5, so we go on the y-axis to 5, 1, 2, 3, 4, 5, right there. Okay, and then that will be a horizontal line. And then we go to the second equation, which is x equals negative 7. So that goes on the x-axis to negative 7. And that's going to be a vertical line. Okay. And we see that our lines intersect here at this point, which is negative 7, positive 5. Which I'm sure some of you had already figured out, since y can only be 5 and x can only be negative 7. That's the only possible solution we could have come up with. So that's your examples. Now you need to work on solving systems 4 worksheet.